Now there is a potential shortcut we can talk about briefly, and that happens under certain circumstances. So here are the four equations again. Remember, these first three are given to you on your equation sheet. The last one is not. If either the initial or final velocity is 0, and we let the object start at position 0, then we can make the shortened forms of these equations by making v naught equals 0 and x naught equals 0. So we get v equals at. X equals 1/2 at squared. V squared equals 2ax. And finally, x equals 1/2 vt. There they are on your equation sheet. That's what they look like. Top left, first three equations. I know your equation sheet is going to look a little bit different than this, but the form has not changed. Solving physics problems. Simple examples 1 through 8. How to apply the equations to predict what will happen. All right, to solve a problem dealing with motion, we're going to use a 5-step process, guess. Because if we don't know what to do, we're just going to guess, right? No. Guess is a process that allows you to organize your thoughts. You do not have to use guess if you are more comfortable, and as you develop your own thinking on this, then you can branch off. But in the beginning, the guess method is a very simplified way to remember what you need to do, because when you're trying to pick out from those four equations, it can be kind of confusing and difficult. But if you follow this precisely, then you will have no problem, I hope. Given. G is given. So write each piece of given information in the problem as a simple equation, as a symbol equal to a number with units. U is unknown. Write the unknown you're solving for as a symbol equal to a question mark. E is the equation. Choose an equation or equations that has the given symbol and unknown symbols and no other symbols. S, substitute, plug in the numbers for each given symbol, and then finally solve for the unknown. Following slides show the application of the guess method using the equations we have gone over. 1 through 5 are simple examples, 6 through 10 are complicated, and 11 are examples of a problem called a proportionality problem. Here we go. Simple example number 1. An airplane accelerates from rest at 5 meters per second for 10 seconds. How fast does it travel at the end of this time? Given information, A equals 5 meters per second squared, and T is 10 seconds. U, we're looking for how fast, so that tells us we're looking for a velocity. So we'll put a V with a question mark. E, what equation can we use? What equation relates A, T, and V? Looking at your notes, you can see V equals AT. This equation has a V, has an A, has a T from rests. We're coming from rest, so there is no V naught needed. So we get V equals 5 times 10 by substituting in. For that first S, the second S, we're going to hit the enter button on our calculator, and that shows it. Speaking of calculators, please show your work. Please write down that E step, regardless of if you're branching off from this guess. You will earn points by selecting the correct equation. So do it. An object is dropped from the roof of a building that is 125 meters tall. How much time before the object strikes the ground? Given. What given information are we? Pause it. Try it yourself. X equals 125 meters. A equals 10 meters per second squared. That 10 meters per second squared is hidden in the problem. Because an object is dropped, that means it's undergoing free fall. And we know that free fall means we have an acceleration of 10 meters per second squared in the downward direction. What is unknown? The question is specifically asking us how much time. So time is unknown. Equation that we can use. What equation relates x with acceleration and time? It's x equals v naught times t plus 1/2 at squared plus x naught. Dropped means we start from rest, so we can use the shortcut equation. Now to use the shortcut equations, you gotta remember them. And the only way to remember them is to practice. Or make flashcards and write them down and study the different equations. Not a bad idea to start on this since we're still kind of early in the year. Memorize your equations in the shower. Look at them before you get in and then recite them while you're in the shower. Because what else do you have to think about but physics, right? S, 125, so we're substituting in here. 1/2 10 t squared. Now, for the substitute portion of the guess method, you can do one of two things. You can substitute right in there and then solve using your algebra. That is perfectly fine. I like to solve for my variable first. So let me show you what that looks like. So this is going to be my starting point. So if I'm looking for t, then first thing I'm going to do is get rid of that fraction because that fraction is scary. And to get rid of that fraction, I'm going to multiply by its reciprocal on each side. So I'm going to multiply by 2 on each side, and that'll go away. And what I'm left with is 2x equals at squared. And then to get t all by itself, I can divide by a. And that goes away, and what I'm left with is t squared equals 2x over a. But the question is not asking for t squared. Instead, we would square root all of that to get t equals square root of 2x over a. And then you can plug in. It's a preference thing. I like the practice of rearranging the formulas without plugging in numbers because you're not always going to be given numbers. So it's good to see it either way. Hit the enter button on your calculator and we get 5 seconds. We'll pick up 3 in the next one.